Morning, Monica. I hope you are able to hear my voice.
Good
Chaitra, is
morning,
it okay? Okay, okay. Is it okay? Shall I continue?
sir.
Yeah, okay, no issue. Others will let us join free time. I'll start with that. Because anyway, we'll go with some preamble. Then we can go for the rest of the part as well. Last class, when we discussed about the Earth's atmosphere, particularly how much we know about the Earth's atmosphere and other properties we dealt it. And we also dealt with the structure of the atmosphere. This is your curricula, what it was specified in Unit 1. Okay. Red color, what I am showing is almost covered in previous color classes. We might have to relatively longer duration covering the rest of it. But thing is that we are not aware of these atmospheric properties well in advance from your earlier studies. Okay. Just before the internals, we covered the vertical structure of the atmosphere, particularly in terms of its density, pressure, mean free fall, and pressure. Compared to the temperature, pressure intensity shows a and linear decrease, sorry, exponential decrease with the height wherever you go, either from the equator or from polar region or from mid latitude. At the same time, the temperature shows its profile. It decreases as you move away from the surface of the Earth, vertically upward, since because Earth acts as a source. After reaching some height, about either 10 km over polar region or 15 to 17 km over equatorial region, it changes its direction rather than decreasing temperature. Temperature starts increasing mainly because of the existence of the high amount of ozone in the atmosphere. Means to say, ozone contribution does not exceed the atmospheric constraints what you expect, even though it is a trace element, even though it is lesser in concentration. Relative to the surface, the ozone contribution in the ozonosphere, we can call, or at stratospheric height, almost at a height of about 25 kilometer to 50 kilometer, it's quite dominant because of high ozone or because of the rich in the contribution of ozone in the stratospheric region. Ozone absorbs the ultraviolet radiation relatively at a higher level, means or greater level, and thereby increasing the temperature. Above mesosphere, that is after crossing the mesopause at a height of about 50 kilometers, temperature again starts decreasing and makes the replica of the troposphere. Troposphere and the mesosphere, they are one and the same thing. The decreasing temperature or decreasing trend in temperature at mesosphere is made because both density and pressure drops. Of course, pressure drops, we can call it also as a density because the drop in the pressure means the number of molecules which are available relatively relatively with reference to the surface is quite less. Means almost about a 2 or 3 order of magnitude less. 2 order of magnitude means if you expect 1000 hectopascal or 1000 millibar is the pressure at the surface. If you reach the mesosphere, the pressure drops to about 1 millibar, 1 millibar. Of course, at a height of about 100 kilometer, it goes about 0.001 millibar, 0.001 millibar of that kind, almost 6 orders of magnitude change in temperature. Again, after mesosphere, that is, the thermosphere starts, temperature simply starts increasing till you reach the sun. Till you reach the sun means, of course, maybe physically or through the satellite or any kind of mode. We stopped at that time. And of course, I also covered the winds in the atmosphere, like precipitation. And we'll try to see that atmospheric gas loss, virtual temperature, and hydrostatic equation, what is shown in red in color. I may not go to up to that extent. I will try actually. Last class, I pushed up relatively. Last few slides very fast actually. You may not able to notice it. Okay? I will repeat it because it is not a good way to skip the topics for better understanding. Yeah, this I do. This we understood. This we understood. The majority of the atmosphere of the Earth is about primitive atmosphere, okay? Hydrogen and helium, and these gases, hydrogen and helium, were lost to the space. That means escaped from the Earth's gravity because of the low gravity or weak gravity. Do you have any query? Okay. This is the beautiful picture. It is not the diagram which is written actually. It is taken from a satellite. The atmosphere did not always look like this. Means always means white patches are with the cloudy regions. The top white patches are with the what we can call polar regions. Green color with the land mass. The blue color shows that oceanic environment. And right side you can see right top actually you can see it did not always look like that. It is a representation. Okay. We discussed we can use ideal gas laws to describe the air properties, like either in terms of pressure, or in terms of density, or in terms of gas constant, like mass, which is weighted out of that, okay, or maybe temperature. That's why it obeys the ideal gas law. Means atmosphere, any gas has to obey the ideal gas law. Okay. Sometimes may not be ideal, but at least it has to obey the gas laws. Okay. This is the expression. Based on that, we discuss the pressure, temperature, density, pressure, temperature, and density variations. What happens here? I took the two examples here. Wind also come into the picture. What you mean by wind? Movement of air mass from one point to the another point, either horizontal or vertical. Since pressure gradient exists from lower surface to the upper atmosphere, near to the surface of the earth to the upper atmosphere, vertically upward, pressure gradient should be such a way that pressure drops exponentially. Because of the decrease in the pressure, always air mass has to move from high pressure area to a low pressure area. Always it has to move from high pressure area to a low pressure area. If that is the case, kindly mute yourself or I will mute you all also. Uh, uh, most main, but thing is that what happens even though the pressure drops, entire atmosphere was not exhausted. Still, it is there because the gravity pulls the atmosphere. Means gravity attracts the atmospheric molecules and tightly bounds the atmosphere to its under its control. All the planets, suppose any of all the planets whoever possess the atmosphere are bound to the that planet mainly because of the gravity. In the sense, compared to the pressure gradient, gravitational force of attraction predominates or dominates. Because of the higher gravity, relatively higher gravitational force, the atmosphere still exists for the Earth and also for the other planets too, whoever the case. Here, we can expect in such a way that gravitational force is due to the gravity of the planet. Pressure gradient exists mainly because of the temperature gradient. If the surface is warmer and upper atmosphere is cooler, assume if the surface is warmer, upper atmosphere is cooler, what do you expect? The heat has to move from region of a high temperature to the low temperature. Certainly, molecules will gain the energy near to the surface and moves upward. That will happen during daytime. After sunrise, solid earth gets warmer. Because of the warmness, whichever the air molecules which touches or approaches the surface of the earth gets warmer. If they gets warmer, they gain the energy and they move along. Thereby, if they why they are moving along, two reasons is that one thing is that as soon as they gain the energy, the molecules will expand. Once the molecules expands, density reduces. As the density reduces, the gravitational force acting on those molecules reduces, the molecules will move along. You might have seen that after sunrise, that is, maybe during sunrise, you might have seen that the fog which is near to the surface. Once sunrise happens, slowly the fog gets disappeared. Where it will go, it will not be converted from one phase to the other phase. That's one case. But at the same time, as the molecules gain the energy, they expand. Because of the expansion, they go to the higher altitude in terms of the height, and they may be making the formation of the clouds, or maybe dispersion will happen. Vertical dispersion will happen. Once they reach the greater heights, about few kilometers, about 1.5 kilometer, horizontal motions are prominent. Thereby dispersion will happen. At the same time, this I shown, I stopped, I maybe might have interacted with about a few minutes actually. See that these are the beautiful example for how wind has to move. Left extreme shows in such a way that during onshore wind or offshore wind. Shore in the sense coastal line, either Goa or Mangaluru or Vishakhapatnam or Chennai or whichever the place you feel actually in India, maybe other places also, maybe Konar. If this is the case, what happens during daytime? Daytime, what happens? Daytime, Earth will gets warmer. If Earth gets warmer, one second, sorry. Earth gets warmer. At left extreme, you see, Earth gets warmer. Uh, Ocean becomes relative cooler. If it becomes warmer, means ocean acts like an high pressure area. Cold temperatures are lower temperatures are the regions of high pressure, and regions of higher temperature are the low pressure areas. Because of that, wind will move from ocean to the land, either ocean wind or onshore wind, off ocean, OWF, off ocean or onshore wind. For the wind, always will tell the direction from where it starts actually. Okay, not where it goes. Okay, it may go wherever it want. In the sense, depending on the pressure gradient, means wind directions are typically reported as the origin from which wind blows, such as westerly wind coming from west direction, easterly wind coming from east direction, wind coming from oceanic wind moving onshore wind means it's moving towards the onshore shore means that is the coastline onshore wind. Nighttime it gets reversed. Land becomes cooler with high pressure area. Means the land and the atmosphere above that becomes cooler and becomes a high pressure area. Ocean becomes warmer. See that the gradient has to move towards that. Almost it is a down slope. Wind will move. Wind in the sense air mass will move from land to the ocean. This is an oceanic. It is a land to the ocean actually. This left side is oceanic wind and it is a land wind actually. Means the nighttime what happens if the air mass moves from land to the ocean, it also takes away the air molecules along with the pollutants. Think of the nature's beauty. If pollutants are migrating from land to the ocean means above the atmosphere, then where they will sink in the ocean and gets diluted. Means ocean are the good absorbers of all the pollutants. This ocean means oceanic water are the good absorbers of all the pollutants. Even though the 70% of the earth occupied by the water bodies in ocean, maybe the combination with other reservoirs also, they are the good absorbers. Means the life exists on this planet because of this balance. If there is a disturbance for this balance, life becomes a tough task. Counter examples use the adverbs, for example, onshore, offshore, upwind, downwind, like that. We can use whatever you want actually of that kind. This one case. Here, this also I shown the same case. It can be off breeze, on breeze, or sea breeze, or maybe land breeze they can call. During pressure surfaces, what will happen actually? This is the sun is there. During daytime, land gets warmer and air mass will move upward. And this is the low pressure to the high pressure. Pressure builds up here. High pressure to the low pressure towards the ocean and sinks over the oceanic environment because ocean acts like a high pressure and land acts like a low pressure. This breeze will happen. This is the clockwise direction. Okay. During night time, the same thing gets reversed. Air mass will move from the land to the ocean, what I shown actually. These two diagrams you remember. The same description, whatever it is written here, you can write in examinations in the ask. Otherwise, for the better understanding, this is the clear pictures. And moreover, see that you should be a good observer while observing any of the phenomena. These are not the simple lines we have drawn actually. These are the lines called the isobars or the lines with constant pressure. See that this is a constant pressure. The difference between these two is quite large compared to here. Low pressure, high pressure, that is why this difference is quite large. Okay, means to say that here height you may go for several hundred meters, here it should be less. If the pressure lines are very narrow, the pressure is quite larger. If the pressure is smaller, assume that about 500 hectopascal, 5.5 kilometer, 5 kilometer we can expect. 5 kilometer is the 500 hectopascal. Here maybe 4 kilometer is the vertical altitude. Within 4 kilometer you will get, because most of the atmosphere is under high pressure actually. It gets reversed. It gets reversed here. Yeah, this is for 2020. I told actually. We can go with the rest of the part also. Advances of the monsoon. Right now we are in May. This is the month for the commencement of the monsoon over India. Monsoon is a season with heavy rain. Enough rainfall, not be heavy you can call, enough rainfall throughout the country actually. Monsoon is a season of rainfall. You may be getting surprised actually. All the countries in the world will not get the rain. In India, preferably, we are getting almost 900 millimeter of rainfall every year. 900 millimeter, if you divide by 10, it becomes 90 centimeter. Almost if you convert to a meter, 0.9 meter. Roughly 1 meter height. If you collect the water from the rain, throughout the India, surface area you estimate, starting from peninsular India, foothills of peninsular India to the Kashmir, and left side Bombay to the Calcutta, if we expect actually. Such vertically you are having almost 4,000 kilometer. Left to right also you are having almost how much actually? No, around 40 degrees latitude. 40 degree, yeah, 4,000 kilometer. 3,600 to 4,000 kilometer is the distance. Is the distance of separation between the two extremes, either from east to the west to the east, or from south north to the south of that kind of. Means if you cover entire India, almost 1 meter thickness water body you can put. You can have an aquarium of 1 meter thickness height throughout the country, wherever you can go. Such a rainfall. Some of the countries like Dubai or maybe Arab countries, okay, they receive the rainfall hardly about few millimeters. 10 millimeter is the annual rainfall. For entire year, they will get only 1 centimeter thickness. Still, they are having a good management to collect the water, because rainwater is the source for drinkable water for the life exists. Even though it is surrounded by oceanic environment to a great extent, we can't use the ocean water. Means maybe some marine life will exist, like fisheries and other things. But the humankind may not survive with oceanic water, okay, to a great extent. Here, these are the lines. You can see that on Indian map, actually, it was going like different colors, like green color and red color. Green color is the actual, right? Actual prediction. Okay, red was the normal. In the sense, what happens always, where I will show you actually. This is this assume that hello. Where we are getting disturbance. Okay, no issue. Okay. Here, Greek color are the one with the actuals. Is first see that here 29 or plus or minus 3 days here. If we get actually, this is the line how that wind goes. Okay, and first or third of 1 to 3, not the minus actually. Between 1st and 3rd June, the monsoon has to go like this actually. In the sense, onset of the monsoon or commencement of the rainfall will happen over peninsular India. Peninsular India means particularly foothills of the peninsular India over Kanyakumari. Means the Kerala receives first rainfall, or regions belongs to the Kerala receives the first rainfall, because the wind will move from Arabian Sea, for example, Arabian Sea towards the land mass. As you go upward, then the dates will up. Means entire belt of this belt will move march fast towards the central part of the India. That is, see that here this is the east. This is the entire country receives the rainfall around 26th June of that kind actually. If you go 4 to 10 June somewhere here, when you will get Bangalore, if the rain starts over the end of May, that is 31st of May, or 1 or 2 days, about 1 or 2 days in June, 1st or 2nd of June, then Bangalore will get rainfall. from June 5th or 6th. It requires some 5 to 6 days for the wind pattern or wind belt to move from the foothills of the India till to the Bangalore. Means we are about 13 degree north, hardly 1,300 kilometer away from the Kanyakumari. 1,300 kilometer linear distance actually. Wind will take some 4 to 5 days to reach from the Kanyakumari to Bangalore. Kanyakumari to Bangalore, not directly. The wind from oceanic environment, they can say that at least. Okay. This is well predicted actually, but sometimes deviations will happen. We will get the rainfall in the month of June, July, August, September. 4 months. JJA, yes, you can call. That is the western, now southwestern monsoon. Southwestern monsoon is nothing but monsoon coming from southwest wind. At the same time, you can also have the rainfall, rainfall, rainfall in the northeastern monsoon. Northeast means it has to come from China or maybe Himalaya to, from the west, from the Bay of Bengal. Particularly places like Tamil Nadu, Andhra Pradesh, even including Telangana, now Odisha, West Bengal will receive the rainfall in the month of the October and November. Bangalore receives the rainfall both in southwest as well as northeast monsoon because Bangalore is about 350 kilometers away from Arabian Sea and also about 350 kilometers away from Bay of Bengal. Means that's equidistant, mostly equidistant. We will get the peak during the month of the July, August, preferably at that extent. Wind also happens. See that mountain breeze they can call, valley breeze they can call. Left side is showing that the top of the mountain is cooler, the base is warmer. Warm air rises and makes the formation of the cloud. Okay, on either side. During night time, what happens, or after sunset, what happens? The heavier cold air mass will breeze towards the foothills of any mountain. Foothills of any mountain means getting cooler. That is why, as you are moving away, as you are moving upward vertically over the mountain, as you are climbing, actually during trekking, you will feel cooler and pleasant air without pollutants and other things, mainly because of the breezes they can call. It makes the circulation in the atmosphere. This is the picture taken at 1803, enhanced water vapor image of the entire South Pole. Intention is that we can take the recent one also. See that it was the first picture with some gradient in color they can call. White patches shows that movement of the clouds actually, how that movement can happen. Because of this circulation only, we are there in the atmosphere. We are there on the earth. This is a diagram from NOAA. Hurricanes are an examples of macro scale. See, these hurricane or even cyclones you can expect. There is no difference between cyclone, hurricane, typhoons. They are all large wind systems. If it happens over India, Japan, over India, we are calling it as a cyclone. If it happens over Japan, we'll call them as the typhoons. If it happens over the America, we'll call them as the hurricanes. The name is by the virtue of the land also. Name is by the virtue of the region also. At the same time, the difference between cyclone, hurricane and typhoon is that wind speed. Hurricanes are much more large in strength. Strength in the sense, wind is quite large in the mid latitude. Wind is not up to that extent in the lower latitudes. India comes in the low latitude up to 30 degree north, of course 36 degree, still it is within 30 degree north actually. Okay, low wind means no cyclones will happen between the equator, from the equator 5 degree north to the 5 degree south, because cyclones arises or origin of this type of disturbances happens mainly by the Coriolis force. Earth rotates from west to east actually. During rotation, atmosphere also rotates. This rotation of the earth makes it a cyclic. This is the one actually. See, this is a direction actually you can call. The width of this hurricane is hardly of the order of about 2,000 kilometer to 3,000 kilometer. Remember, this is the eye of a cyclone. 2,000 kilometers is the diameter of a hurricane, and it makes certainly a devastation once it approaches. The height of the cyclone or wind pattern, we can call actually, okay, is hardly about 1 kilometer. Base of the sea is about 1 kilometer, and the top can go to the extent of 15 kilometer. 15 kilometer. Horizontal disturbances be about 2,000 kilometer. 2,000 kilometer. But rain will not happen at the eye. Rain will happen at the periphery. Peak rain will never get. This is a low pressure area. As you go upward, the pressure decreases. It is not of our concern now for this class actually. Because global circulation, what I expect, I shown these diagrams in the previous class, but I could not be able to explain you in fully. It hurts me also. I should not skip the slides. I should not jump on just for the sake of the completion of the syllabus for you actually. What happened? Equator gets warmer relatively compared to that of the mid-latitude crustaceans or maybe polar regions, mainly because the, the radiation falls perpendicular over the equator are the regions with the high temperature zones. Once the atmosphere receives the radiation from the sun, air mass rises up vertically up and move towards the polar region and sinks over the polar region and makes a circulation. This circulation is known as the Hadley circulation. Hadley was the first person in 18th century may observe this phenomena, a great phenomena of circulation of air mass from the equatorial zone to that the polar zone. Means to say that it makes an unified circulation. Either you write wherever you want. These lines are also the same case. He rises and sinks over. If you understand the northern hemisphere, southern hemisphere is the mirror image or replica of that one actually. Means if not, for example, if the atmosphere is not there, like as that of the Jupiter, as that of the some other planets, what happens actually? Entire planet always getting warmer at one point, and heat means that thermal energy may be transported from one point to the another point by the mode of conduction. You know that how that a metal rod gets warmer, how a metal rod gets heated up actually. If you heat from one of the corner or one side of the corner actually, the mode of the transport of the energy is through the conduction in material or metals. In liquids, it should be through convection, either the gas or maybe any kind. In fact, they will call it as a fluids, both gas and liquid. Together, they will call it as a fluids actually. Convection is the process of transport of the energy from region of higher energy to the region of the lower energy. Region of higher energy in the sense, region of an higher temperature over the equatorial zone towards upper atmosphere, from the upper atmosphere towards the same thing towards the polar region and sinks over. It means warm air at the equator rises and flow towards the poles. Cold air at the poles sinks and flow towards the equator. This makes the circulations. Means, but if Earth is non-rotating sphere, but at the same time, even though Earth a huge dynamic celestial body of the order of about 13,000 kilometer diameter or 6,400 kilometer as the radius actually, okay, due to the rotation, the air mass also rotates along with the Earth. Okay, means you may not expect the 3 cycles. You go for the 1 cycle, 3 cycles. Means Hadley cell will happen here, rises up about 30 degree, it sinks over 23 to 24 degree, sinks over 30 degree, about 66 degree. Again, see that it sinks, moves here, rises, and then moves. First cell is the Hadley cell. Second cell is the Ferrel, F-E-R-R-E-L, Ferrel cell. Third one is the polar cell. You can find the vortex here on either side of the polar regions. Because of this is the central point. The equatorial region always acts like a low pressure region. This is the Tropic of Capricorn and Tropic of Cancer here are the high pressures. Always air mass has to move from high pressure to the low pressure. See that blue color arrows are moving towards the equatorial zone, thereby making the convergence. High pressure areas are divergence, low pressure areas are the convergent regions. Means entire air mass moves towards the low pressure areas. Okay, means bringing the moisture from the 30 degree north and the 30 degree south to the equatorial zone, thereby making the what we can call the monsoons. If this belt is known as the tropical convergence zone, or if it is between the tropics, intertropical convergence zone, they will call actually. It moves towards the polar region along with the advancement of the movement of the sun. Means sunrise always need to be exactly east. Somewhere the radiation will fall perpendicular over the 30 degree north, Tropic of Capricorn to the Tropic of Cancer. March 21st to September 21st, it moves from the 23.5 degree north to about 23.5 degrees south. Almost 47 degrees the variability of the occurrence of the sunrise. Yeah, this is a beautiful picture. Hadley during 1735 proposed that the temperature contrast between the polar region and the equator creates a large convection cell. in each of the hemisphere. Fine, good. It rises up. Why this is height? Because this is the height of the tropopause to a greater extent actually. Imagine the convection will not happen beyond the tropopause to a great extent. Okay, within the troposphere only it has to happen. Okay, the tropopause height is about 17 kilometer to 18 kilometer over the equator. As you go upward, about 8 to 10 kilometer over the polar region. This happens actually. Beautiful thing. Okay, global circulation on non-rotating Earth. Remember, it is a speculation actually. It is a model output. Okay, a simple convection system is produced by unequal heating of the land, unequal heating of the atmosphere on a non-rotating Earth. The same thing in 1920, because as here earlier slide was with 1735 to almost 200 years. We believed only with one cell model actually. They thought that in the 1920, a 3-cell circulation model for the each hemisphere, okay, was proposed. What it says that, see that air mass rises, Hadley cell. Here, subtropical high spill up. It acts like an horse latitude because horse latitude was the horseshoe magnitude you might have expected. Navigating, particularly the fishermen, they use it to move from one country to another country, one point of the globe to the another point of the globe through the navigation by making use of the magnetic direction by using the magnets for the needles, whether they move towards north or south of that kind actually. This is the polar fronts of that kind. This happens. This is beautiful thing actually. Okay. Yeah, here the same case. This is the equatorial. I told that earlier. Equatorial low, they can call intertropical convergence. So here subtropical high. This is also subtropical. Always air mass will move towards the polar regions during one side, one time of an the direction. After 6 months, it gets reverse. It has to move from here to here in the sense reverse. Okay, in the sense. This is moving from east to the west. Okay, after 6 months, it will move from west to the east of that kind. Actually, it is an imaginary because of the rotation of the Earth. It becomes semi-permanent. See that earlier diagram looks like a straight line of that kind. You write it straight in this more or less curved path, but always it may not be because we are having a mountain, land, and all entire atmosphere. Entire Earth is not heated up uniformly. Ocean gets more warmer. Land gets cooler during daytime. Night time. During daytime, land gets warmer and ocean gets cooler. During summer, land gets still warmer compared to the temperatures. The real Earth, with disruptions of the zonal patterns caused by the large land mass. This is American map shown. You can show the Indian map also. These disruptions break up the pressure zones into semi-permanent in the sense H regions with H are known as high temperature or high pressure they can call. Preferably you go with pressure. This is the in terms of the pressure they have put actually. Okay. This is H is with the high pressure. This is H with the high pressure. This is with H with the high pressure. This is with the low pressure. Low pressure or high temperature they can call. From high pressure, air mass is diverging. See that it is diverging away from the region. Diverging away from the region. Okay. Using this, they can estimate that which is the direction. The wind always moves from high pressure to the low pressure. We can estimate. If we estimate in the sense, if we calculate the wind between the 2 points, then you can say that whether wind is approaching or wind is moving away. Yeah, this I thought of showing you the Asian monsoon circulations over Asia. Okay, there is no barrier for the wind. There is no discrimination between India or Pakistan or Sri Lanka or America or on ocean or on land or on agriculture land, non-agriculture land. Only thing is that it has to move from, certainly it will move from high pressure region to the low pressure region. The Asian monsoon circulation is the biggest monsoon circulation in the world because this is having a great phenomena where India is covered with the oceanic bodies on the three sides, that is left side with the Arabian Sea, right side with the Bay of Bengal, and the foothills with the Indian Ocean actually. Means on the top, only the land mass. That is why it not be restricted for India. It is for the entire continent of the Asia they can call actually. South part of the Asia belongs to the, is a great contribution from the Indian side, occurs in conjunction with the seasonal shift of the intertropical convergence zone. Blue color, you can see that with the development of the cyber. This is the subsidy. High pressure will happen. Okay, because of this high pressure, and including the Tibetan Plateau and Himalaya, air mass will move from the northeast towards the ocean. This is the polar. This is the warmer region. This is the cooler region. High pressure to the low pressure. High pressure to the low pressure. This is a dry, cool continental air will move from. This is during the winter, November, December. Okay. After 6 months, see that blue color line has shifted towards the India and of that kind. Means wherever this line moves, okay, that is associated with the wind. That is associated with what we can call the precipitation pattern. That is associated with the monsoon pattern to a great extent. To a great extent means you observe the two diagrams. I will show. I will flip between the two. See that blue line is down. Blue line moves upward after 6 months. Summer monsoon is associated with moist air, with more water vapor, with more warm temperature. If you feel more warm during daytime, around before noon hours, about 1 o'clock or 2 o'clock, you will get a rain in the afternoon or evening hours. This changing wind pattern. See that this is southwest monsoon, I told. This is the northeast monsoon. Atmosphere is dry. Here it is wet. Atmosphere is wet here. Wet in the sense because of the humid air. Okay. Cherrapunji is the region where it gets enough rainfall in the world actually. Okay. Particularly the southern part of the China region. Here, this wind is nothing but the change in the monsoon season from southwest to the northeast. If you take for India, this is the all India rainfall. Almost 1080 centimeter they have quoted actually. Average annual rainfall is about 1000 centimeter, 1000 centimeter, 1 meter height actually. 1 meter height. Now, 1 meter height actually. 1 meter height. See, January, February will get line. End of May or June is the peak month actually. See the peak June, July is the peakest month. Then it drops down August, September, October, November, December. Means June, July, August, September. These are the enough amount of the rainfall. Most precipitation is expected. You see that this is about 350 millimeter of 350 centimeter. They are saying that if you add them put together, you get about almost 900 average I can say 900 to 1000 centimeter of rainfall. Why it happens? Okay, don't get worried this type of a diagram. What you want to drag is that you draw 180-degree west to 180-degree east here, 180-degree west, 180-degree east. Remember where India comes. India comes somewhere here, 60-degree east to 90-degree east. In terms of the north, about 5-degree north to about 36-degree north actually is the coverage of the area. If you write the top left one, bottom panel is for the May and June, where see that this is the pressure line, this is the pressure line, this is the pressure line. May, June, we are seeing that enough rainfall, this color patches, enough rainfall over the India. Over the November, December, winter season for the India, rain is near the Australia. This is the Australian monsoon. Circle, you can see that Australian monsoon. Here, this is the Asian monsoon. Here, left is American monsoon, either west of the America or North or South American monsoon. There are three monsoons here, either American monsoon, Australian monsoon, or Asian monsoon. Okay, America comes here actually. Sorry, this is the Africa part. I missed it. This is the African monsoon. The American monsoon is also recently added. But compared to the all four regions, okay, Asia receives a good amount of rainfall. Even in the Asia, particularly India and neighboring countries, receives the good amount of rainfall. This is the map of the world in terms of the temperature contrast between winter and summer. You can also classify this in terms of the pressure. What I want to say is that assume that January, okay, so take same case, okay, nobody worries. You just put India, otherwise latitude, longitude, you write 90-degree west to the south, 90-degree east to the 90-degree west, okay, north to the south. H is the region of the high pressure, L is the region of the low pressure actually. What happens where you can find the India somewhere? India is here. Always if you draw India and Sri Lanka, we will notice it where it should be of that kind actually. Okay, it should be just above the equator. which type of an equator? It is not magnetic equator. It is the political equator. Magnetic equator passes through the India exactly at the Tumba, Trivandrum. Trivandrum. That is the beauty of the nature actually. Okay. Here, Bermuda High, you can expect that. Bermuda Triangle, you might have seen that. Everything gets diverged from that point actually. Pressure is 1020. It not be 1013 always actually. Pressure is 1020 during the month of the January. This is the region of the cities said. Okay. Okay. Where you can high pressure areas, high pressure areas. These are the low pressures. After 6 months, what will happen? See that in the month of the July, high pressure areas shifts. High pressure area shifts. See, this is a high pressure areas. 1026 high, Pacific Ocean. This is the 1020. India, see the thermal low will happen over this region. Because of this thermal happen, the air mass will move from ocean to the land actually. Even within ocean also circulations will happen from eastern part of the America till to this extent actually. If you get actually, the Pacific Ocean is almost about 140-degree coverage. It means 14,000 kilometers the coverage of the Pacific Ocean. Almost 12,000 to 14,000 kilometers you can say from west to east part actually, thereby making circulations to a great extent. Yeah, this is the winds at 925 hectopascal at the pressure. This is the surface wind at 1000 hectopascal here, 1000 hectopascal. This is the winds. See that the top panel is during the winter, bottom during the summer. Here what happened? This is the southwest monsoon. See India, you can see here India. Okay, southwest monsoon means ocean is quite warmer. Which ocean? Pacific Ocean and then Indian Ocean. Indian Ocean is getting warmer and the land is not up to that extent. And land, particularly this belt, getting warmer and warmer. Because of this, it is wind is moving from east to the west. Easterly wind over the Pacific Ocean. Easterly wind over the Pacific Ocean travels as it approaches the land. The temperature is quite prominent compared to this African region. India and South Asia gets warmer and warmer and makes the circulation, attracts the wind or draws the wind from this direction. That is why changing the wind direction, changing the direction of the wind at least by 120 degree. See that this is the east to west. Easterly wind moving towards the west changes its direction and becoming easterlies. Instead of exactly the easterlies, this is the south, this is the west. Southwest is the origin, or moving towards northeast. Southwest moving towards northeast is the direction of the southwesterlies and it enters into the India. This is the commencement. It will move towards this point after 2 months actually. Means this type of pattern for entire globe is makes the precipitation. Precipitation is nothing but occurrence of rainfall or occurrence during the season. Season is known as the monsoon season, winter season, summer season, pre-monsoon season, post-monsoon season, like that. Okay, either winter, fall, spring, they are all the classifications. But monsoon means it may have in any form either fog or maybe mist or maybe rainfall. Rain is also one kind of a precipitation. Other countries in the world may not receive much rainfall. Of course, Cherrapunji is the largest one. There is no doubt in that in the world. Okay, it reached almost 10 times more rain than that of the entire average India. Okay, this is during 925 hectopascals means with a height of about 1.25 kilometer. 1.25 kilometer. One second. I come on. Okay. Hello. Sorry. Winds at 925 hectopascal. Winds at 925 hectopascal. 925 hectopascal means at a height of about 1.52 kilometer. 1.52 2 kilometer. Why I'm putting range? Because from the mean sea level 925 is known actually. From the solid surface of the earth it is different height actually. 1.5 to 2 kilometer is the what must be the direction of the wind. If you take near the surface, because of the surface features like land or ocean or valley, you may not get this pattern. This is standard height of 925 hectopascal. See that this is the Asian monsoon. Good. Australian monsoon. Then Australia, African monsoon of that kind. One second, I'm getting some disturbance. Okay. This is the rainfall pattern. In the sense, you during rainfall, see that India receives much more. It just put a circle, that is more than enough. You put a circle in the Indian region, it receives more rainfall during here, here, here. Here, less. Means during December, January, February, rain is more over this region, like Australian region, Australian region. Yeah, this is also the same case with precipitation. I don't know whether you notice it or not. Actually, it happens in such a way like during January, and this is during July. The scale, these type of graphs are known as Surfer graphs. Don't worry. It also indicates the range. See that if you move with left extreme, 20 millimeter of rainfall, the right extreme with 340 millimeter of rainfall. Wherever you are getting green color, about 180 millimeter of rainfall, or around yellow color, about 220 millimeter of rainfall, they can go with color code. It is a three-dimensional picture because we can't go with number, no? That's why wherever you see this color, actually what must be the amount of the rainfall during that month, they can see that. Okay, leave it this. Okay, very wet over tropic region, and there is a seasonal shift between the northern hemisphere and southern hemisphere, and monsoon regions exist like Asian monsoon, African monsoon, Australian monsoon, American monsoon also. Extremely dry subtropical highs you can expect. Mid latitude regions gets more summer rains. Okay, mid latitude, okay, around 45 degree. July rainfall looks like a map for forest cover. July in the sense, see, if you are getting a map, cover map, if you are getting a terrain map with the forest, actually, wherever the forests are there, the rainfall is wherever the forests are there. If you take a map of a forest, if you take a map of an heavy rainfall, wherever it has happened, the correlation exists between forest and the rainfall. Means to say that people are saying that plant a tree, maintain a tree, don't go for deforestation, don't go for cutting a tree. That number of trees, number of forests makes the planet Earth relatively cooler and comfortable with good amount of rainfall. That only as a physicist can tell. Okay? This is how it has to go. They classified only for the purpose of the studies, not else actually. They classified the entire India into different regions. Different regions means this is the Western Ghats can call. This is the Eastern region. This is the central part of India. This is the west part. 1, 2, 3, 4, and 5. What happens here? Region 1, what must be the amount of the rainfall? One can see that. Region 2, what must be the amount of rainfall you can expect, particularly during mean precipitation over India throughout the year. Okay, starting from January, February to December, if you put actually, see that on one, where is the one? One is on the top. Western Ghats receives the largest amount of the rainfall throughout the year. See, this is the commencement, end of May, June. This is the trace amount of the rainfall. It goes up, shoots up. Fine. Almost 20 millimeter per day. Per day rainfall, I am saying that 20 millimeter per day. Then it is coming down. June. Where is the month? August. June, July, August is the end. Then September still there. Then by the end of the September, it starts decreasing. Where region 2, see that here rain will start only by where this is the region by September, October or November. See that this is the line. This is the October or November. October, November, so not October, even October and November. Okay, after July, then it is the peak is at during November. Then it starts decreasing. Regions over these regions. This region, no choice. Number 3, see that starts somewhere with the same case 3, then follows 4 over Rajasthan and Gujarat and deserted area, less rainfall. Among the regions, region 2 receives very less amount of rainfall, followed by 4, followed by 3 is the good amount. If you take the average of all those things, average pattern follows the number 1. Average pattern follows the number 1 to a great extent. This is the Indian average. Just to remember actually. Based on this, okay, this is up to one concept. What I thought of explaining in the previous class, somehow I shifted. Of course, still it may took 1 more hour additional for me, not an issue. We are having the next topics with the atmospheric gas class. Okay, don't worry. I will not go much word by word. You are well aware. You studied all gas laws in your chemistry earlier today, and those who are not studied in chemistry, maybe in physics also, you learn particularly in thermodynamics. Okay, like what are the gas laws? Atmosphere is nothing but envelope of different gases like nitrogen, oxygen, and argon put together 99.9%, about 0.1% with the trace elements, less of the trace elements. This atmospheric gases also obey the ideal gas laws. Which are the ideal gas? I will go by statement. Laboratory experiments show that the pressure, volume, and temperature of any material can be related by an equation of the state over a wide range of conditions. Okay? Equation of state is, what is the equation of the state? You can write there should be a balance. All gases are found to follow the approximately the same equation of state, which is referred to as the ideal gas equation. Ideal in the sense it is behaving in ideal behavior, ideal manner. It is an extremely good as in one kind of a certain, okay, ideal gas. Means in terms of the temperature or pressure and the volume, they have to behave. Means there is a criteria. There is a criteria. It will never deviate. For most purpose, we may assume that atmospheric gases that may be considered individual like nitrogen, oxygen, argon, or combination of all of them put together along with the trace gas elements, or as a mixture, they have to obey the ideal gas equations exactly. This section, whatever here, considers the various forms of the ideal gas equations and its applicability for the atmosphere. There are two kinds now, wet atmosphere or dry atmosphere. Dry atmosphere is nothing but atmosphere without water vapor content. Wet atmosphere is nothing but amount of water vapor is nothing but atmosphere with the moisture. Of course, dry air is also there. Dry in the sense, dry air in the sense, dry air in the sense, dry air in the sense only the dry atmosphere. Wet air means it is a combination of the wet air, water vapor content. During summer, atmosphere is enough water vapor content over here. During winter, atmosphere will lack of water vapor content or moisture in the air. Because of this lack of moisture, we are applying moisturizer. Maybe skin can go crack. Maybe you will use the more lipsticks also to a great extent to reduce the crack of the skin because that's very sensitive. Lips are very sensitive skin actually. Even legs will go crack. Okay, skin over the legs will also go crack because of the lack of the moisture. Okay, face will also be it becomes a little bit brittle and hard to a great extent. Okay, that's why we are using the moisturizer. Imagine places like in Dubai or the Europe, where the Africa or such type of an kind actually, the temperature crosses 45 degrees Celsius. Okay, during summer. Okay, here you are Bangalore, you are always very comfortable with 35, 36 degrees Celsius with peak temperature. I'm saying that otherwise less than 30. Okay, almost it is an air conditioned environment. No air condition is required for Bangalore to a great extent. You can enjoy. Okay, only thing is that you come to the class, physical classes, at least some 10 minutes earlier, you'll get relaxed in 10 minutes and it becomes cooler. Here, the ideal gas equation will be written as PV times MRT or N times RT also you can use. Sorry, it is N times RT only. Pressure times volume must be equal to RT or N by volume gives you the density terms. For an unit mass, for example, if M is equal to 1, for example, okay, if M is equal to 1 kilogram, then what comes? This 1 by V, 1 by V, 1 VV, 1 by V becomes V by 1. Volume becomes, okay, for volume for 1 kilogram, they can call alpha times RT, where alpha is the specific volume. Specific volume is nothing but the volume occupied by gas for 1 kilogram. 1 kilogram for a mass of 1 kilogram, how much volume it occupies? 1 kilogram mass occupies either 1 liter or 2 liter or 1 meter cube or 10 meter cube or 1 kilometer cube or 10 kilometer cube. We don't know. That depends on the pressure and temperature. Okay. If 1 kilogram of mass, that is unit mass, occupied in a volume is known as the specific volume. specific volume. Okay, alpha is nothing but what you to take that m over v. M over v gives you the alpha value. What happens? Being this, we can derive the laws. If all the laws you know that Boyle's law, Charles law. Here, if the temperature is constant in PV times is equal to N times RT, if temperature remains constant, then this equation reduces to the Boyle's law. What it says that if temperature is fixed for a mass of a gas is held constant, then the volume of the gas is volume of the gas is inversely proportional to its pressure. PV is equal to N constant. Volume is proportional to the pressure. Means if pressure increases, volume decreases. If pressure decreases, volume increases. Okay. Or if you raise the volume, pressure has to drop. If decrease the volume, pressure has to be built up for a chamber or for a condition with control system. Okay, means the volume of the gas is inversely proportional to the its pressure. PV is equal to constant, or P is inversely proportional to the V, 1 over V. Change in the physical state of a body that occur at constant temperature are called the isothermal. This analysis. This implicates the same equation, are the Charles 2 laws. What it says that the first of these laws states for a fixed mass M, for a fixed mass of a gas at a constant pressure, fixed mass and P is equal to constant, the volume of the gas is directly proportional to the observed temperature. If mass is fixed, pressure is fixed, volume is directly proportional to the temperature. Is the first law. Yeah, Charles law. Second Charles law says that for a fixed mass of a gas, here M is fixed, within a fixed volume, pressure of a gas is proportional to its absolute temperature. Both are the same case. Okay, here the first case is volume is proportional to the temperature, or pressure is proportional to the temperature. Okay, otherwise, either V should be constant or P should be constant of that time. These are the Charles laws. Charles laws. Just remember what your laws. Being this, there is a temperature concept in the atmosphere known as the virtual temperature. Don't get excited actually. Means moist air has a smaller apparent molecular weight than the dry air. Beginning, I asked some questions, okay, maybe several also. You may have tough found the answers for that. You might have written or maybe still remembering. You might not have found time for to explain or give answer for my queries to the earlier classes. What I want to say is that clouds are floating. Why clouds has to float? And moreover, floating is not a simple phenomenon. If you estimate the mass of a cloud, for example, about a diameter of about 100 kilometer diameter, with a thickness of about 10 kilometer, 1000 diameter 10 kilometer, sorry, okay. If you estimate the volume, pi r, okay, make it as a cube. Make it as a cube actually, with a height of about 10 kilometer height, and diameter or width is about 100 kilometer, and breadth is also about 100 kilometer. Then what happens to the volume? This is 100 into 100 into 10, almost 5 zeros. 10 to the power of 5 kilometer cube is the volume of the cloud. 10 to the power of 5, or make it as 10 to the power of 6 is the volume of the air. If that is the case, if 10 to the power of kilometer cube actually, 10 to the power of 6 kilometer cube, if the density is 1 kilogram per meter cube, 1 kilogram per meter cube, then this is the 1 kilogram is 1000 into 10 to the power of 6, means almost 1 million ton. 1 million ton is the mass of one cloud. 1 million ton is the weight of a cloud. Weight or mass, if you put, no issue actually. Weight or mass in the sense, not interchangeable words actually. Weight of a cloud becomes to be about how many kilograms? At least 10 to the power of 6 kilograms. 1 megaton, 1 million ton. 1 million ton is the mass. Then if that is such a high mass, why the clouds has to float actually? How the clouds are flowing? How that's moving actually? Because it carries a moist air. Moist air is having a less density compared to that of a dry air. Because of that moisture, because of that combination of the water Okay. For example, I will. This is the same relation it is showing here. Here, apparent here we can call. This is the real gas constant. You know that real value is about 10,303. Sorry, 8.3145 is the real gas constant value. 1,000 times that divided by the molecular density of the air. Particularly taking the molecular density, atmosphere is made up of majority of the nitrogen. Like nitrogen is 14 and 7n14. 14 into 2, that is 28.97 is the molecular weight. If we divide this by this and multiply this by 1,000 relation, we will get 287. Real gas constant is 8.314, but for the dry atmosphere, the value of the real gas constant for atmospheric constraint is about 287, 1/4 of this value, almost 1/4 of this value. Okay, 287.04 joule per Kelvin, degree Kelvin per kilogram means a gas constant, for example, of 1 kilogram of mass air, 1 kilogram of moist air is larger than that of the 1 kilogram of the dry air. In a sense, gas constant for the 1 kilogram of the moist air is larger than that of the means how much energy is required for you to move the moist air from surface to the top. Rather than use a gas constant for example, moist air, the exact value of which would depend on the amount of the water vapor, because you can't do it actually, which varies considerably. It is convenient to retain the gas constant for dry atmosphere. This is for dry atmosphere. For the moist air, it should be different as a fictitious temperature called the virtual temperature. Otherwise, virtual temperature is the temperature required to raise and 1 kilogram of air from surface to the greater height. From surface to the greater height. What is that greater height? Where the gas constant remains constant. Virtual temperature is a temperature. Virtual temperature is a temperature where the energy required to rise the 1 kilogram of the dry air to the desired height where the two energies remains constant. Means density is equal to density of the dry air, mass of the dry air to the mass of the mass of dry air to the mass of the virtual over to the volume. This gives you the summation of those things. Means potential temperature or virtual temperature is also one temperature for the measurement. Yeah. Pressure as a vertical coordinate, how it works. I will stop at this point actually after discussing this relation. Okay. Pressure at a pressure, how that pressure can pressure as a vertical coordinate, or you can also call it as a hydrostatic equation. Means atmosphere is stable. Static atmosphere is stable means it is stable in terms of the stable. It is stable in terms of the stability. Okay. If it is not stable, if it is an unstable phenomena, atmosphere might have moved from surface to the upper atmosphere, then to the outer space. Here imagine a volume of an air. Okay, this is the surface of the earth or ground they can call. This is the top of the atmosphere. Let us choose. Pressure decreases. Yeah, you know that. Let us P should be the pressure, and V should be the volume, and rho should be the density. Z should be the height. Here, what we'll expect? Consider a volume of that kind. Delta Z is the height. Pressure is the P, which is acting here upward. Pressure P plus delta P acting downward. Okay, P plus delta P acting downward, and rho times G times D delta Z is the density. This is the height. This is the region of our interest. At any given point, column of air with unit cross section 1 meter by 1 meter, 1 meter square, or 1 kilometer by 1 kilometer, 1 kilometer square. Okay? Starting from surface till to the top of the atmosphere. This is the reference point. Pressure drops as you move upward. You know, pressure drops as you move upward. That is directly proportional to the density times the difference of the height multiplied by the acceleration due to gravity. In this limit, delta Z tends to 0 because assume that there is no much change in the distance here, or delta P, rate of change of pressure with height, is nothing but negative sign of acceleration due to gravity times density. Otherwise, it should be a constant. Delta P over delta Z is proportional to the minus rho. Means density drops, pressure drops as you move upward. G is constant value. Of course, G does not change much appreciably within 100 kilometers to a great extent. But for practical purpose, but theoretically, if you speak for every meter, the G will also drop 9.80. What you take 9.80 or 9.81, 9. Maybe 79 something, 9.76 of that kind of. Okay, negative sign because the pressure drops. The vertical velocity component in x, y, and the p coordinate relates in such a way W is equal to delta P over delta T, or the time rate of change of pressure experienced by air parcel as they move along the three-dimensional trajectories throughout the atmosphere. Because of this, horizontally pressure may drop about 100 Pascal for a 1 day, daytime to nighttime. But at this rate, it would take about a week for an air parcel to rise or sink through the depth of the troposphere. Means from top to the bottom, if you come, it will take about 1 week time actually. If x, y normal case, P is the pressure for the Z direction, vertical velocity. So what will happen? W is equal to, see, delta y by delta x, delta P by delta x is along x direction, delta P by delta y along Z direction, delta P by delta x is along x, that is towards east. Delta P by delta y is along y direction, that is towards north or south. Delta P by delta z, if you take, that is along vertically upward or downward. W component is that the rate of change of pressure with time, rate of partial pressure with time plus the V dot del P plus W times del P by del Z is the expression for the flow of the wind along the W direction. Means W is equal to this expression, del P by del T is that minus G times rho times W, del P by del T can keep plus V time. Okay, means this del P by del Z is, for this del P by del Z is substituted minus rho times. Or this W is equal to, because rate of change of pressure with time is ignorable, gradient in pressure is also less, it gives you W is equal to minus rho times G, or where wind should be minus V times del dot Zx in any of the direction. Because of that, you'll get the hydrostatic balance. How that hydrostatic balance we can happen, you can say that same thing, dW, del W or dW, dW over dt is equal to minus 1 over rho times del P by del Z. How that pressure changes with height. This is minus the acceleration due to gravity. This is due to the Coriolis force. This is last term is due to the frictional force. Friction force added up. Coriolis force adds up for the change in the pressure along the wind direction. And acceleration due to gravity is the suppression from the Newton's second law. How to say it? This is the hydrostatic balance. If they ask the hydrostatic balance equation, you have to write. I'll see that how it works actually. The same thing I'm telling you here in a nice manner. For example, if assume that fluid is at rest, the pressure at a point P here depends on the weight of the fluid. I'm sure that vertically above how much the pressure which is acting on it. The pressure difference between the 2 points, okay, on the same vertical line depends only on the weight of the fluid between them. Here what happens? G acts downward, no doubt. Pressure acts upward. Here on the top, P, Z plus delta Z should be acted on the top. For upward force which is acting on the top, the pressure difference between the 2 points, what you are expecting actually, depends only on the weight. The upward force is what? How much is that upward force? This Pz times delta X and delta Y. What is the downward force? Z plus delta Z, which is the pressure, times delta X plus delta Y. Along with that, gravity also adds up here. There are 2 forces. Of course, negative should be there here, no doubt. Negative is taken outward, minus G times mass of the mass within that sample. Because of this, at the equilibrium, what happens? These 2 forces gets balanced. P times Z plus delta Z. For example, here this over delta Z, delta X, delta Y, delta Z throughout the volume plus M times G is equal to constant. This can be written in such a way. This delta X, delta Y, delta Z as the V, rate of change of pressure with height dot V plus m times g is equal to constant. Or divide this throughout by the volume del p by del z. M over v gives you the density. Okay, density, it should be the constant. This equation is known as the hydrostatic equation. If they ask for the expression for the hydrostatic balance, you have to write these two. You have to use these two slides. It implies that there exists a balance between vertical pressure gradient and the gravity. For an atmosphere at rest, hydrostatic balance holds exactly. Now, take the assignment. What is the hydrostatic balance equation in a coordinate system with pressure as vertical coordinate? If that is the case, you have to write this answer. Then equation of the state will come into the picture. The same thing. We are familiar from the elementary physics with Boyle's law and John's law. They are special cases of the equation of the state. PV is equal to N times RT is the perfect gas equation, where R star is equal to 8314 joule per Kelvin per degree Kelvin per mole is the universal gas constant, and N is the number of molecules. Okay, if for mean molecular weight for nitrogen about 29, and this is the equation of the state. Okay, equation of state, either you use PV times nRT, RP is equal to R times rho RT also. And for the dry atmosphere, the mu comes to, sorry, R comes to be R star over mu. R star is 8314 divided by 29 gives you about 287. Yeah, I'll stop at this junction with the equation of the state. I thought of explaining the concept of one second. Concept of this. Yeah, virtual temperature, hydrostatic equation, geopotential, scale height, and hypsobarometric equation. Then these things I will take it up in next class. Thank you. I'm sorry for disturbing you on your Sunday with some leisure time, but we are also having some time limitations. If you are having any doubt, I'm very happy to answer, or you can interact with me anytime. And these videos are always available. Anyhow, I will share this in your Telegram. Then that's far better also for me. Yeah, you are there in the English. Enjoy. In what is shared, you can also see that whatever I told. Thank you. I'll stop sharing this screen first. If you are having any particular query, I'm happy to answer. For all there, Aruna, Chaitra, Supriya, Ramya, Rupa, Naveen, Kavya, then Lara, Likit, Yashaswini, Trupti, Monisha, Kavya, KR, Prapulla, Sahana, Lakshmi Devi, Maulya, then Anusha, Sagar, Ashwini, Annapurna, Sandhya, Pooja, then Tunga, Madhu, Sahana, Nishchita, Geetanjali, Venkatesh, Chaitanya, Sohama, Sushma, Sushmita Kesi, Shruti, Anchana, Sharma, Girish, Chetan, and others. Okay, can you exit right now? Thank you anyway. Was it clear? I will share this slide right now immediately. Both slides.